Okay, this is going to be a super basic, quick video. The last part of your assignment today, you're going to graph or plot a complex number on the complex plane. So I just want to do a quick introduction and then you'll get a more detailed introduction in the next video. So the complex plane essentially was created, right, to help represent complex numbers in a way that made sense to mathematicians and allowed them to maybe look at more opportunities for applications of these type of functions. So the complex plane essentially looks like a coordinate axis. So we have what we call the real axis here, and then just like the y-axis, we have what we call the imaginary axis. So this we label as real, this we label as imaginary. And I know maybe it hasn't been super important in the past to label them as x, y, or real imaginary, but if you're plotting complex numbers, it's important that you do represent that with real and imaginary so we know the difference. And then essentially we have tick marks, right, just like all other coordinate axes, and we move so many units in one direction, and positive and negatives represent the direction on the complex plane. So remember that complex numbers, if I wanted to plot a complex number, the standard form for complex number is a plus bi, or in other words, we have, right, the real portion right here, followed by the imaginary portion. And when you're plotting these numbers, you're just going to use this as a coordinate pair, so kind of like an xy plane. If I have the numbers, say 3 plus 2i, then on my coordinate grid I would go 3 units in the positive real direction and 2 units in the positive imaginary direction, or on the imaginary axis. So I would go, again, if this is, I'll use my laser tool so we can see it. If I'm starting at the origin, I would go 3 units in the real direction, and then I would go up 2 units in the imaginary direction. And essentially my complex number is represented by this point on the graph right there. So that point right there would represent the complex number 3 plus 2i. Okay, if I wanted to graph another one, so let's say I was graphing the complex number negative 6 plus I. In this case, I would go negative 6 in the real direction because that's the real number part, and then this would be a positive 1 because it's like there's a 1 there in the imaginary direction. So I would go negative 1, 2, 3, 4, 5, 6, and then I would go up 1 in the imaginary axis direction. So this point right there would be represented as that point on the graph, so that would be negative 6 plus I. So you can see how the negative and positives in relation to the real and the imaginary parts are just representing coordinate directions on the complex plane. If I wanted to go backwards, so let's say we were given the point on a graph that was right, I'm going to draw this and hopefully you can tell where it is. Let's say it's about right here. You can tell where that is. So if I wanted to write the complex number for this black dot right here, I would just count how many units it is over in the real direction. So it looks like we went over 1, 2, 3. And then it looks like we're going down 1, 2, 3, 4. So if I went 3 units in the positive real direction, and down, meaning subtraction, 4 units in the imaginary direction, this would be the complex number 3 minus 4i. So today you're going to just plot a few of those values on the complex plane. And then you will be asked to look and discover what a modulus would be. So go through and see how you can do with that. Essentially, it will ask you to take one of these complex numbers and connect it to the origin. So as you look through kind of the partial key, if you haven't been able to find a solution for that, it will give you an indication of what you might be able to use to help you find the modulus of that complex.